What determines F1 carbon fiber chassis load path design? Imagine a race car zooming around a track, twisting and turning at high speeds. Every force from acceleration, braking, or hitting a bump has to travel through the chassis smoothly. That's where load path design comes into play. It's all about guiding these forces along the strongest routes within the structure. When engineers design a Formula One chassis, they focus on making sure these force paths are optimized for safety, performance, and durability. First, safety regulations set the rules for impact absorption and driver protection. The chassis must handle crashes from different angles without breaking apart or hurting the driver. Engineers design load paths to channel crash forces away from the driver and into parts of the structure that can absorb impact energy safely. They also make sure the chassis can withstand the constant stresses from racing, like cornering forces and vibrations. Performance is another big factor. A stiff chassis helps the car handle better and transfer power more efficiently to the wheels. To achieve this, load paths are carefully planned to make the structure as rigid as possible without adding unnecessary weight. Using computer simulations, engineers test how forces flow through the chassis and adjust the design to improve stiffness while keeping the weight low. This balance is key to making the car fast and agile. Material properties also influence load path design. Carbon fiber is a popular choice because it's incredibly strong and lightweight. But it's anisotropic, meaning its strength depends on fiber direction. Engineers align the fibers along the main force directions, like front to back or side to side, to maximize strength where it's needed most. They use different layup strategies, combining unidirectional and woven fibers to match the expected load patterns. The chassis doesn't work alone. It connects with the suspension system, which transmits forces from the wheels to the chassis. Load paths are designed to transfer these forces efficiently, reducing flex and maintaining precise handling. Aerodynamics also play a role. The shape of the chassis and its load paths support the aerodynamic surfaces that generate downforce, helping the car stay glued to the track. Manufacturing constraints are another consideration. The design must be feasible with advanced composite techniques like autoclave curing and precise fiber layup. Engineers plan load paths to follow the natural flow of the material, reducing stress concentrations and ensuring consistent quality. In essence, the load path design of an F1 carbon fiber chassis is a careful mix of safety, performance, material science, integration with other systems, and manufacturing practicality. It's a finely tuned process that results in a structure strong enough to handle the demands of racing while keeping the weight as low as possible.